What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, we're going to talk about operations with scientific notation. Specifically, we're going to talk about adding numbers in scientific notation. Now, if you aren't familiar with scientific notation or you're struggling with scientific notation, then definitely go watch the video on scientific notation, converting from standard form to scientific notation, as well as another video converting from scientific notation to standard form. That's going to be the foundation for this video. Now, let's get right into the examples, and we're going to show how to add using scientific notation. Okay, so I have 2 times 10 to the 5th power, and I want to add to that 3.8 times 10 to the 5th power. Now, when they have the same power of 10, it's relatively simple. All we have to do is take the first number and add them together. So I'm going to put them together in parentheses, right? And let me use a different color. So I'm going to say 2 plus 3.8. All right, and I'm going to keep that in parentheses. And then we're simply just going to say times 10 to the 5th power, because you have 10 to the 5th power here and there. All right, so now 2 plus 3.8 is simply going to give me 5.8, and then I bring down the times 10 to the 5th power. All right, so that one is, like I say, fairly simple when you have the same power of 10. We're going to do one more example like that from the negative side. Okay, let's look at example 2. All right, example 2. Let's say I have 7.2 times 10 to the negative 6th power, and then I want to add 5.44 times 10 to the negative 6th power. All right, same thing. We still have the same power of 10. So all I actually have to do here is take the 7.2 and the 5.44, add those together, and then multiply that by 10 to the negative 6th power. Okay? 7.2 plus 5.44 is going to give me 7 plus 5 is 12. So 12.64, if I wrote that right. Yep, 12.64, and then times 10 to the negative 6. Now, here's the thing. This cannot be our answer because this is technically not scientific notation. Why? Because this first number has to be between 1 and 10. So it has to be greater than 1, but less than 10. All right. So what we can do is we can actually move this decimal place 1 to the left. Now, when I move that decimal place 1 to the left, it's like dividing by 10. So this is going to be 1.264 times. Now, if I divide this first number by 10, I need to multiply this one by 10. Well, if I say, let's write this right here. So if I say times 10 to the 1 power, remember when you're multiplying exponents, you have to add the exponents. So they have the same base, so we can simply just add the exponents. Well, negative 6 plus 1 gives me negative 5. So this is going to be times 10 to the negative 5 power. Now, that's our final answer because this first number is between 1 and 10, and then this is times a power of 10. All right? Let's keep going. So now, this example, We're going to switch it up a little bit. We're going to switch it up. All right? Switch it up. Let's say I have 5. So let's say I have 5 times 10 to the negative 5 power plus 2.46 times 10 to the negative 3 power. Alright, or as I like to say, the negative tree power. Y'all check out the video on the number tree. So, in order for me to add these two, I have to have the same exponent. Okay? I have to have that same power of 10 in order for these to add together. And so what I'm going to do is I'm going to change this one to make it 10 to the third power. So what we can do is we have to manipulate these exponents. So 5 times 10 to the fifth power is the same thing as saying 5 times 10 to the, remember I need a negative 3, so I'm going to say negative 2 times 10 to the negative 3 power. Now I'm going to be honest with you, it bothers me to write those x's to show multiplication because I like writing a dot or parentheses. So that's just a random thought in this video. Alright, so now we have a 10 to the negative 3 power just like that. So let's keep that in parentheses. Alright, and as a matter of fact, let's change this right here. Let's put that in a different color so you can actually see. Alright, so then we're going to add 2.46 times, and I'm going to say 10 to the negative 3 power. Because I want you to see that they both have those in common. Alright, so they both have a power 10 to the negative 3 power. Now we can put them together. So 5 times 10 to the negative 2 power actually is just like saying 0.55, and then we're going to say times 10 to the negative 3. Alright, so all I did was 5 times 10 to the negative 2 power is 0.55. Alright, so then I'm going to take that and add that to 2.46 times 10 to the negative 3 power. Alright, now we're simply going to do like we did in the first two examples, and we just add these. So 0.55 plus 2.46, and then times 10 to the negative 3 power. Alright, so if I add these together, I'll get, what is it? 2.5, it looks like I added a number wrong. Something is wrong. You know what? I know what I did wrong. This should be a 0. Whoa. Correction, like Rafiki used to say in The Lion King. This should be a 0. I knew something looked weird. Alright. Even the experts make mistakes. Remember that. So if you see this, remember, even the experts make mistakes. Alright? So 0.05. This should be 0.05 because if I have 5.0 and I move the decimal 2 places to the left, I have to have 0.05. Alright? So just to kind of hit that fact check. Alright, so now I get 2.51 times 10 to the negative 3 power. Alright, 2.51 times 10 to the negative 3 power. That is my final answer. Alright, now pause this video and go back, or rewind it and go back and watch that piece again. Okay, watch that piece again. That's why we do these. Alright, so you can actually pause it and take the time to get it. Let's do one more example. Example 4. And I want to have 9.7 times 10 to the 6th power and plus 6.7 times 10 to the 5th power. All right, let me make sure I got my problem written right. All right, that is correct. So now we need to have these exponents to be the same. So what I'm going to do this time is I'm actually going to write and use the 10 to the fifth power. Okay, so this can be 9.7. Erase that. 9.7. All right, times 10 to the 1 power, and then times, or let's do that in black, times 10 to the 5th power. All right? So now that we have those, plus 6.7 times 10, and let me do that in green as well. All right? All right. So, got to make sure those colors, because I want you all to see exactly what's going on. All right, so now we have a 10 to the 5th power here, a 10 to the 5th power there. Now, 9.7 times 10 to the 1 power is just 97. Okay, so I have 97 times 10 to the 5th power plus 6.7 times 10 to the 5th power. We're going to add 97 plus 6.7 and then multiply that by 10 to the 5th power. This gives me 103.7 times 10 to the 5th power. This is not scientific notation though, because this number is not between 1 and 10. So I need to move this decimal place to the left. Boom, right there. So now I get 1.037 times 10. Remember, now if I divide this first number by, technically I'm dividing it by 100. By 100. So if I move this decimal place 2 places to the left, so if I divide this first number by 100, I need to multiply this by 100. So what that looks like is times 10 to the 2nd power, because 100 is 10 to the 2nd power. So now I end up with, remember, I have same base, add the exponent, so 10 to the 7th power. All right, so that would be the final answer. All right, this is adding numbers in scientific notation. Thank you for watching. Make sure you hit that subscribe button. Dana Harris, Young Gurus Math Tutoring. I got the solution to your math problems. Deuces.